That makes sense. All right, we're doing today, we're simplifying square roots. What'll help today, I put the yellow factor sheets out on your table, so if you want to share with the person next to you or have your own, those will come in handy. So simplifying square roots, we all know what a square root is. The other name for a square root is a radical, not because they're like super awesome, that's just the name we give them. So to simplify square roots, first you have to know what your perfect squares are. That's what we're going to be used to simplify square roots. We're going to use perfect squares. Perfect squares are just your counting numbers multiplied together. So like 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 4 times 4, 5 times 5, so on. So the list goes all the way up on this list. It goes up to 15. We're going to be seeing which one of those perfect squares divides our square root evenly. So our first property, we're going to use multiplication. So that really where this all comes from is that if we have the square root of, let's say we have a times b, we can split that up into the square root of a times the square root of b.
Can I use the factor sheet?
Yeah. And then we ask ourselves some questions. And I put all the questions on here, so when you're going through your homework, it's super easy to follow. First question you're going to ask yourself, is the number a perfect square? If the number is a perfect square, then you just have to take the square root of that. So if you were given like the square root of 25, 25 is a perfect square, so the square root of 25 is just going to be 5. If you have the square root of 49, your answer would just be 7, because the square root of 49 is 7, or you get 7 times 7 gets you to 49. Question number 2. If it is not a perfect square, you're going to see what is the largest perfect square that goes into it evenly, or divides it evenly. And then from there, you're going to simplify. You're going to write your answer as the answer of your perfect square, so you get a whole number, and then you'll have a square root along with it. I'll go through the examples, and then the steps will start to make more sense. So we're going to use our factor sheet, so everybody have that handy. Square root of 75. Everybody find 75 on your chart, and we're going to list out the factors of 75. So the factors of 75 are 1 in 75, 3 in 25, 5 in 15. So in the 6 numbers that I wrote down, which one is a perfect square? Michaela, which one's a perfect square in the 6 numbers that I wrote down? 5 and 15 is a perfect.
1 and 7.
No. Which is the largest perfect square in that list? 3 and 25. So what we do, 25 is our largest perfect square. So we split up square root of 75 into the square root of 25 times the square root of 3. Square root of 25 is a perfect square now, so then we can simplify that to 5. And then we have times the square root of 3. And we can't simplify the square root of 3 at all, because if you look on your factor chart, the only perfect square that goes into 75 is 1. Sorry, that goes into 3 is 1. So this is our final answer. 5 times the square root of 3. This is what we would call an exact answer. You could put this onto your calculator and you get out an approximated answer. We're keeping everything as exact answers.
Yeah.
This is also the same value of square root of 75. They're just written differently. One simplified, one is not. All right. Example B. First question you ask yourself, is 16 a perfect square? Yes, so we would take the square root of 16 to get that. It's 4 times 4. So we just say the square root of 16 is the number 4. Not the square root of 4, but the number 4. All right, that one's easy. Example C. We have a negative in the front now. We have a negative in front of our square root symbol, and we're going to keep that as we simplify. So again, as you practice these, I would just write out the factors of 32. We have 1 and 32, 2 and 16, 4 and 8. Which pair do we want to use? Why 16? Why wouldn't I use 4 and 8? 4 is a perfect square. 16 is the largest perfect square. You always want to use the largest one. So we're using square root of 16 and the square root of 2 when we draw our little factor tree. Square root of 16, square root of 2. The square root of 16 is 4, like we just did in the last problem. And then square root of 2, the only perfect square that goes into it is 1. So you can't simplify square root of 2 at all. And we just have to keep that negative in the front. So our final answer would be negative 4 times the square root of 2. Between those two terms, there's multiplication happening. Again, we would call this an exact answer. We're keeping everything today as exact answers. All right. We'll keep going through here. 121, is that on your perfect square list? Yes, no, maybe? Yes, it is. So how do we get to 121? What two numbers do we multiply together? Boba, what two numbers do we multiply together to get 121? Michaela, do you know? They don't hit each other. 11. So this is 121 is on our perfect square list. So we would say this is your answer would just be 11. All right. Here's some time you're going to have to practice on your own. Try doing letter E by yourself. If you don't know where to start, my first hint would be to write out your factors of 50. All right, so the factors of 50 that we can use are 1 and 50, 2 and 25, 5 and 10. 25 is the only perfect square in this list, so this is the pair that we use. So we can break up negative square root of 25, square root of 2. This negative stays. 25, square root of 25 is 5 times square root of 2. This is your final answer. If you were to type this into your calculator, you would get out a decimal. We do not want the decimal. This decimal is the same if you were to type this into your calculator. These two things are the same. One is simplified, one is not. Yes.
Does it matter what order you put the 25 and 2 in? Does 25 to go first?
I always put, when I split up my little tree like this, I always put my perfect square first. Because when you get to this point, you always want to put your number in front of your square root symbol. So if you always just put your perfect square first when you write it, then you can just keep dropping things down. Makes it a lot easier. Because writing your number in the back of the square root looks kind of clunky. All right, last example on the first page. Can somebody tell me what are the factors of 46? So 1 and 46, 2 and 23, are any of those perfect squares? Is 23 a perfect square? Is it on your list? No. Is 2 on your list? No. 46 is on your list. 1's on your list, but that's not going to help us at all. If we were to split this up into the square root of 1, square root of 46, the square root of 1 is just 1. So it'll be 1 times the square root of 46. So moral of the story, not all roots can be simplified. If there is not a larger perfect square, a perfect square greater than 1 that evenly divides your number, you cannot simplify your root and you just leave it as is. Unsimplifiable. All right. There's everything simplifying with multiplication. We'll flip to the back. We'll use division now. So division, we follow a similar rule. If you were to have the square root of a divided by b, we can split that up just like we did with multiplication. That is equal to the square root of a divided by the square root of b. So the first question you'll ask yourself is, okay, well, what does a square root of a fraction look like? Well, it looks like the top and the bottom split up, square root of a and square root of b. You're next going to see if you can simplify any of the radicals. If either of these are perfect squares, you want to simplify those right away because that's easy. Step number 3 is kind of the longest step in the process. It's called rationalizing the denominator. In normal people talk, that just means getting the square root out of the bottom. When we write our answers, we do not want square roots in our denominator. So we're going to follow a process to get them out of the denominator. And then the other 2 steps are just to simplify your fraction. So, example A. We look at what our fraction looks like. We have the square root of 3 25ths. Using our rule, we can split that up into the square root of 3 divided by the square root of 25. Which one of those is a perfect square? You all should say 25. So 25 is our perfect square. So we can simplify our denominator to 5. Square root of 3, if you look on their factor chart, it's only 1 and 3. So that means there's no perfect square other than 1 that divides 3. So we can't simplify it at all. So we leave our answer as square root of 3 over 5. All right, we'll keep going. Example B. We can split it up to square root of 4 divided by square root of 36. What's the square root of 4? Well, to get to 4, we take 2 times 2. So square root of 4 is 2. Square root of 36, we would take 6 times 6. So square root of 36 is 6. This is not your best answer because 2/6 we can reduce. See, there's the karaoke popping up. You guys weren't here. I sang karaoke this weekend. That's why my voice is cracking more than usual. All right. So 2 divided by 6, that reduces to 1/3. All right, so 1 over 3. All right. Problem C, this is the most as difficult as your problems will get. So there it is again. So square root of 12, square root of 15, we'll split those both up. Neither of these are perfect squares. 12 isn't a perfect square, 15 isn't a perfect square. So what we're going to do is we have to get rid of this square root of 15 on our denominator. We do not want it there. So the process is really easy to get a square root out of your denominator. You're going to multiply by whatever you see on your denominator. So we see a square root of 15. So I'm going to multiply the top by a square root of 15 and the bottom by a square root of 15. What this is going to do is make a perfect square on the bottom, which then we can turn into a whole number. All right. Rules for multiplying square roots. Just like I had on the first page with the square root of a times the square root of b is the square root of a times b underneath the square root. Square root of 12 times the square root of 15 is the same thing. We take 12 times 15 and keep it underneath that square root. So this is equal to the square root of 180 divided by 15 times 15, that's 225. So this is divided by 225. Is 180 a perfect square? No. Is 225 a perfect square? Yes. So this, what is the square root of 225? 15. 15 times 15 is 225. Right. So we have 15 divided by a square root of 180. We don't want to stop here. We want to see if we can simplify this at all. All right. 180 is not on your factor sheet. So if it's not on your factor sheet, you have to go through a guess and check process. All right. You're going to look at your perfect square list. So everybody flip back to the front page of your notes. What perfect square is closest to 180? It would be, what's the next one up? 196. So we're going to start checking which one divides it evenly. So to check, we'll take 180 divided by 196. If you were to do that, you would get out a decimal. So we know it's not 196. If we were to check 180 divided by, what's the next lowest one after 196? Look at the list on the front. 169. If you were to divide those two, you would get out a decimal. Your next lowest one would be 144. You divide those two, you still get a decimal. We're looking for when we divide until we get a whole number. So if we were to keep going, if we get to 180 divided by 36, we get out 5. So we know 36 is the largest perfect square that divides 180 evenly. So we can write off to the side, kind of do our 180 is the square root of 36 times the square root of 5. Multiply 36 and 5 would get you to 180. And that we can simplify, because 36 is a perfect square. So we can write 6 square root of 5. And that is our numerator now. 6 square root of 5 divided by 15. Again, this could be an okay final answer, but not a great final answer, because we can reduce 6/15. 3 goes into both of them evenly. 3 goes into 6 2 times. So we could say 2 square root of 5 over 5. That would be our final answer. Because if not, it's a bad answer. Because in math you want easy numbers to work with. If you were to plug this to plug in is a lot easier to plug in this. Where are you going to use an outside rule?
multiplication and addition. What? Where do we use this?
I don't know. I don't know the future when you're going to use it.
Where?
Where do you use it?
Where could we use it?
Analyzing. We'll get to word problems later in the chapter, but we'll talk about like the path of a ball. You can talk about the cost of something over time. Because the word deals with words and numbers. There's not just numbers and there's not just words.
We already deal with words many times.
All right. We'll do these last few examples. Example D. We can split up into the square root of 25 divided by the square root of 11. 25 is a perfect square, so we can write this as 5 over the square root of 11. Again, this would be a bad answer because we do not want this on the bottom. All right, we have to multiply it to the top and the bottom by the square root of 11 times square root of 11 times square root of 11. So when you're multiplying a whole number by a root, think of them as like fire and ice. You don't want the two to mix. So we just write this, our numerator, as 5 times square root of 11 over, these two are the same, but with a root, so you can multiply the two together. So this would be the square root of 121. And then we just have to look, we made a perfect square in our denominator. So that simplifies then to a whole number. So on the denominator we have 11. On our numerator we have 5 times the square root of 11. 5 over 11 we can't reduce at all. There's no number that evenly divides both. So that's how we leave our, this would be an exact simplified answer. You'll notice that when you do this whole process of rationalizing the denominator, the number that you start with is always going to be the number you end with without the square root. If you get a different number, that means you multiplied wrong. So use D as kind of an example and try to do example E on your own. So do this on your own. Show all your steps, simplify, and make sure your final answer is as reduced as you can get. Well, then do your work and then it won't be awkward.
Are we done?
No, you're doing this one on your own. It says do this. Yeah. Yeah. So this is square root of 7.
I don't want you to respond when I'm talking about teacher.
Shh. Let's wait. Then you two, you wait also. Square root of 49 is 7. This is square root of 13. So to get square root of 13 out of the denominator, we got to multiply both by the square root of 13. So you'd have 7 square root of 13 divided by 169. So 169, the square root of that is 13. Again, it's the number that we started with without the square root on it. And then 7 times square root of 13. So that's your final answer. You can't simplify 7 over 13 into anything nice. Other example, E. Square root of 81 is 9. Square root of 16 is 4. So that's your final answer, 9/4.